Hi, this is Alix Paultre, and I'm here today at the S3 Semiconductor booth at the Embedded World Show with Darren Hobbes. And, well, we're always talking about embedded in this place, but you have a very special interest in this because you do mixed-signal chip design, right?
Indeed, Alex. Thank you for having me. Hi, I'm Darren Hobbes with S3 Semiconductor. So S3 Semiconductor is a company where we focus on mixed-signal RF integrated with embedded processors. That's our speciality. We've been doing it for the last 20 years plus. So we regard ourselves as a company who's democratizing access to silicon. So we deal with companies regardless of the volume that they do. And that's quite unique, right? And the reason why it's unique is because there's been so much industry consolidation in the last number of years that it's very, very hard for companies to have a direct dialogue with semiconductor companies, purely because there's been so much consolidation. They're into big volume and they're into maximizing the margin. We're not. We're into supporting the small guys. So that's what we do. So we understand the economics of silicon. So for example, we've got a very good tool here that we have online, and what it does is it shows the return that you get when you do integration. Now, integration of ASICs is not expensive. It's exceptionally cheap. It's never been cheaper. Why? Because the technology nodes are there, 0.18 is there, 65 nano is there, and it works perfectly for devices at the edge, right? So you can integrate RF, you can integrate mixed signal, you can integrate any kind of core you want, whether it be from ARM or any of the other vendors. You can integrate any kind of communication protocol, whether it be wireline or wireless. We can do all of that, and we can integrate it into a single die, and that's a key benefit. So if you go to a calculator here, I'll give you a demo. If you just go online, you can see you can put in a very, very simple item, such as you put in the volume that you're running per year, how many years you're running it for. Then you put in the number of, let's say, high-performance data converters you may have on your board, which you have other analog components. What kind of processor do you have on board? So we have a scale of 1 to 4. 1 would be, let's say, a basic M0 from ARM. M2 might be an M3, M4. And then if you go to 4, that could be like, let's say, data center type processor. Then we have other elements such as how much memory you have, whether it's RAM or it's flash. And then do you have some kind of RF connectivity? Now that RF connectivity is more like an ISM band type connectivity as opposed to, let's say, wireless backhaul type connectivity. Okay, and then you do the calculation, and you come back with a very, very simple graph that shows the difference between a discrete solution, which would consist of all these components, which are highly margined, by the way, because you can't get access to them. You have to work through distributors, or you go with us, and we provide an integrated solution. So you can see initially there's a bit of it. There's an NRE charge. You can't get away with that, but the accumulated cost over the lifetime of the product is a hell of a lot less than if you go with a discrete. And you can see, for example, in this case here, there's a saving of $16 million, right? And that's with a fairly basic edge device where we integrate a lot of mixed signal, embedded processors, and communication interfaces.
Well, and the other thing is, I think what's important to bring out is that you really are targeting these companies that can't get the big boys to help them design. And you've got, because when you think about that, today's engineers, you know, they want to pick up the phone, they want to talk to an FAE, they need help with their design, they need dial-in. And if you're talking to someone who only takes 10 million orders, it's kind of hard.
Yeah, exactly. And I mean, so it's in S3's DNA to have a direct interaction with the customer. So we have no FAEs, we have no application engineers. What we do is when we engage with a customer on a custom chip development, we put our system architects and our engineers in direct dialogue with their engineers. So there's nobody in between. And that's one of the key selling points that we have. And in fact, over the years, anytime we've done surveys with our customers, that's the response we've got back. Listen, we love you guys. In fact, your engineers are almost better than our engineers, and we want to work with you. So what happens is we tend to get involved at the very early stages of system design, and it works really, really well that way.
Well, you would have to, I imagine, because this isn't something you can just say, hey, I decided to make a chip and let me just throw some stuff together.
Absolutely. I mean, it's absolutely. So the more holistic you can be in your upfront requirements generation, the better you can. So that brings me on then to the edge space, right? So we all heard about edge computing, autonomous edge. It's become very topical at this point in time because people realize that a lot of computing can't actually be done in the cloud, because when you go into the cloud, you got a communication overhead, it's costly. You also have a security issue because you're bringing direct access to your edge, plus control at the edge has to be done real time. And anytime you have latency in communication, that really screws with your loop control. So what we've done is we're democratizing access to silicon for the edge, and we've an example of what we've done yesterday. In fact, we've launched a new product. It's called Smart Edge Platform. And what the Smart Edge platform does is it integrates all the components you need at the edge, whether it be analog front ends for various kinds of sensors. Because sensors are notoriously nonlinear, you need to integrate some kind of calibration. We can integrate that. If you want to control your edge device, if you want to control your asset, we can integrate in processors. basic processors like PIC microcontrollers, or even something like an M series from ARM. We can do that too. We can put any flash, any RAM, we can put any OTP in there, right? Then if you want to communicate to the cloud for uploads or updates or assessment of how your asset is doing, we can integrate security. The security we use is hardware security, and it's the best you can get as opposed to software. And then communication, you've got a whole choice of communication. So we can integrate in any of the industrial wireline communication protocols, whether that be HART, whether it be Foundation Fieldbus, Profibus, moving to Ethernet. We can integrate those beautifully, right? And then if you want wireless communication, which is starting to emerge a little bit in the industrial space, we can also do that, right? It's off the shelf. So really, the bottom line is that the Smart Edge platform is an opportunity to come up with a single chip solution for your edge device, so you end up with something that's optimized both in performance and in cost. And I guarantee you will not get that from any of the other semiconductor vendors out there. We're the only guys that can do that, because we're the only guys that will talk to you and help you to do that.
Excellent. So now, where do they get information? What's your URL?
So if you go to s3semi.com, if you log on to s3semi.com, in there you'll find a link to our Smart Edge platform. Have a look in there. Also, we've got access to our online calculator. If you want to do some quick sums, have a look at that as well. And again, it's a good way to get engaged with us.
Excellent. So hey, thank you so much for taking the time at this very busy show, and I really appreciate it.
Thank you. Thanks, Alex.